Alrighty. Well, thank you everybody for joining us today, and hopefully we can give you a little bit better insight into what IGS can bring to your mills in respects to an alternative solution to the plaguing sulfidation corrosion matters that you have in a lot of your assets within your mills. What we're going to do today is try to give you a little bit better understanding on our metal spray technologies. We have a very unique and different form of metal spray that is highly different from what most mills are accustomed to and may have been utilizing in many years past, in like the 70s and the 80s, early 90s. IGS has provided or introduced to the pulp and paper industry a form of metal spray that is highly advanced in regards to technologies and additives that we utilize not only in our metallurgies, but also in our means of conveyance through our application equipment. As Marina said earlier, I have about 30 years experience in this industry, both in obviously with thermal spray, but also in the pulp and paper industry. We have a very strong knowledge of what is plaguing a lot of your key assets within the industry, such as your black liquor recovery boilers. And we understand the sulfidation corrosion issues that are greatly affecting the lower levels of these particular units. And so we also understand that there has been a lot of upgrades to equipment owners' boilers, where they have gone to upgraded metallurgies for the water wall tubes in these particular units to primarily composite tubing. Which is, a very, very good solution for the sulfidation problems that you have in them. But it's unique in that we've, normally these composite tubings are usually only in the lower 30, 35 feet of the lower combustor. And eventually that corrosion issue will migrate to that interface between the carbon and the composite, where we offer obviously a solution to address that, even if you have gone composite in your recovery boilers. We have also specifically formulated some very impervious alloys for your power boilers, should you have power boilers on your facility site, which are primarily formulated to combat the erosive and potentially corrosive elements or constituents that could affect your power boilers, depending upon your fuel makeup. So we have a good understanding of those two pieces of equipment found within your operations. We are also very well familiarized with both continuous as well as batch digesters. And IGS is probably one of the most experienced contractors in this industry for abating those issues that you would find in digesters. We have the ability to address the corrosive matters in these pieces of equipment with either our trademarked Diarc 360 conveyance, which is a metal spray to very high thicknesses, or we can also offer automated weld overlay to your digesters, so that we can obviously address the corrosion issues. And with our mechanical services, obviously, we can assist in restoring to your code required standards through the weld metal overlay application. And we also have a very specialized alloy that we have developed for the evaporators, which is a slightly different, as you know, probably a slightly different corrosive media because it's very aqueous. So we have a specially formulated alloy that will address those corrosive issues that are found within the evaporators. IGS is a very global source for corrosive and erosive issues, not only plaguing the pulp and paper industry, but a number of other industry verticals that also have corrosive issues. So we are very well respected, as well as bringing some very highly respected solutions to corrosive issues that plague a lot of different industry verticals. What I'm going to try to do today is just give you a better understanding of our metal spray technologies and what you could expect from IGS should the decision be made to utilize our services and our technologies to effectively address your metal wastage issues in any of your assets. Again, like I said, we're very familiar with the Craft black liquor recovery boilers. We know that the wastage is usually found within that lower 30 foot of the furnace. We know that some units have gone to composite in their lower units, or weld overlay, either field applied or shop applied. But we're here to try to bring to you an alternative to those types of solutions through the utilization of our metal spray, which is also proven to be very beneficial in combating against the sulfidation corrosion that plagues your recovery boilers, again, the digesters, your evaporators, and it doesn't really matter what your configuration or the type of evaporator that you're utilizing, be the LTV, falling film, rising film. We realize that there is still a corrosive element within those that is very detrimental. And again, we have formulated a very specialized alloy to combat that form, which is very, very wet or very aqueous as a constituent. What is IGS? And what are we bringing with what we call HVTS, or high velocity? It's basically a very, very long-term, actually, solution to those internal metal wastage issues that you may have in your critical equipment. And it's an alternative to providing an increase in your life cycle and a cost optimization of these solutions. And it's an alternative to either replacement, which can be very costly, can be very time consuming. Weld overlay is another alternative, which again is also very costly, time consuming, but more importantly also has the high heat impact on the substrate, just due to the nature of the conveyance of the material to the substrate. And then of course there's organic systems, but they don't possess a very large range of operating conditions that provide a robust increase to the service life, and not really utilized too much. Thermal spray, there's basically two sources or two means of conveying thermal spray to a substrate. You can either have an electric heat source, or you can have a chemical heat source. The two that we're really going to kind of look at is going to be the twin wire arc, which is the main go-to for application of a metallurgical upgrade. Very old technology, and it has some detriments and some drawbacks. We'll look very closely at obviously the HVTS being made available by IGS, but there's also chemical heat source claddings that are available out there on the market, but they also have some drawbacks based upon the type of the environment that's found within a lot of your assets, from the viewpoint of high heat and the severity of the sulfidation corrosion. Metals in the chemical heat source family, HVOF, which is a high velocity oxy fuel, it produces a fairly dense coating, but it has a lot of residual stresses just due to the nature of how it is applied and the heat that's involved to generate that cladding for your particular assets. Flame spray or detonation, that's usually going to be found more so in a shop applied application, but again, they still also have the effects of a very heat stressed final cladding. The first big thing that you really have to do if you're going to consider thermal spray claddings is that you have to really understand the problem, and that the corrosive environment in paper mills is a very complex constituent. So at IGS, we can isolate those your systems or your assets from those constituents that are found within those environments. And we do that through alloy upgrades and what we're basically doing is upgrading the alloy in your asset to something that's more impervious to the effects of the constituents that are present. And these barriers obviously are what is going to mitigate any further metal loss that is being generated by those constituents. I'm really going to start from this point forward now, really kind of discussing the two main forms of thermal spray that are geared to the issues that are present in pulp and paper, and that being the conveyance method of twin wire arc, or what we'll call TSA, which is TSA only. Okay, so it's a very low velocity application through conveyance. So it's a subsonic gas stream that is carrying the melted particles to the substrate. It is a method of creating those particles that actually occurs on the exterior of the nozzle of the conveyance gun. So what that is doing is it's subjecting the particles that are being melted to produce the barrier to very high oxide contents because of the combustion occurring in atmosphere. Also, it's very low bond strength from the viewpoint of the as applied cladding. And because of the high oxygen or oxide content, you have very high levels of interconnected oxides within the cladding itself, as well as high porosity. With HVTS, which is only available through IGS, we atomize our wire first off in a supersonic gas stream, but it also is combusted inside the nozzle, so that again is minimizing the ability for an increase in oxide content. Twin wire arc, just to jump back to that for a second, this is usually utilizing just standard off-the-shelf wires, which in comparison to what IGS brings to the market, we manufacture all our own wires. So we have a lot of alloy modifications in our wires and in our as applied claddings that help to minimize not only the in-flight oxidation and keeping them at acceptable levels during the spraying process, but it also produces and assists in producing a very key, one of the main key elements of a good thermal spray cladding as applied, in that it has very low residual stresses. So when you have an increase in oxide contents, a non-uniformity of your coating particulates, what you have is you end up with potential pathways. I guess, can I move me? Let me do this. There we go. You have a potential pathway for your corrosive media to permeate through the coating into the substrate and attack the substrate, even though it has been cladded. and would result in obviously further degradation of the substrate, but also greatly affects the performance of the coating itself. When you have permeation, that kind of a coating is very subjected to disbondment or spalling. But when you have particulates or particles rather that are very uniform in configuration and have been able, and we've been able to eliminate that in-flight oxidation, it gives you a very low residual stress coating and less pathway for the permeation of the corrosive species. These next few slides that I'm bringing up kind of give you a good indication of what I'm referring to as far as the oxides that are found in the older technology thermal spray that's available, in that when you look at some of these microstructures, you see these black indications within the cladding itself. Those are embedded oxides within the cladding. When you look at something that our IGS HVTS cladding, it is very dense. There's no evidence of present in-flight oxidation in the final as applied cladding, whereby providing a better barrier, if you wish, to these the sulfidation constituents that plague your equipment. Excuse me. As I said, we manufacture all of our own wires in-house. They are specially formulated for highly corrosive environments. Our 5450 is our main go-to alloy for the higher sulfidation situations that you would find in recovery boilers. It has a very low porosity level of less than 1%, less than 2% of oxides. So what this is really doing is it's providing you a very protective diffusion barrier that's going to protect that substrate from the corrosion, also from the fact that it's also 35% chromium, which is very impervious to the corrosive elements. There was an EPRI study done a number of years ago on this particular alloy composition that we've developed. And it was done in a supercritical PC fired coal burner, which they're also very subjected to very high corrosion rates. And it was found that our 5450 composition was actually 10 times more corrosion resistant than Inconel 625, 622. So it's an excellent alloy to be considered for areas within the recovery boiler that would need assistance in protection against the sulfidation corrosion. Our other composition, metal alloy composition that we have available, and this is our 5460. Again, very low in porosity, very low on the total oxides. It's got great bond strength, and it's a close metallurgical composition to actual Inconel 622 or 625. The only difference being is that, again, we've have those alloy enhancements that allow it to be conveyed to the substrate through our high velocity conveyance and provide a very dense impervious cladding for a little more aqueous type of an application, such as in your evaporators. Performance verification and high temperature corrosion permeation. At IGS, at our Richmond facility, we have our own fully staffed lab, and we are able to actually simulate any type of high temperature corrosion environment, so that it allows us to have a better understanding as to what actual alloy we should be recommending for the application, And it has also been what we've utilized to verify the performances of our recommended alloys for different applications within the pulp and paper industry. And we also have the ability in that same lab to do high temperature sulfidation testing, as well as high erosion or erosion resistant testing. So when we come in to talk to you about some of the alloys that we have available to assist in protecting your assets, we're coming to you with a very large database to back up what we're recommending. When considering thermal spray, you should actually take into consideration 5 very critical factors. And the failure to meet any one of these 5 critical factors, that being permeability, is there an alloy modification? Does the alloy itself or the cladding itself have a high residual stress or a low residual stress? Can it provide you with some proven performance? And are the technicians that are applying this, are they trained and certified? These are 5 key elements that should really be taken into consideration should you be considering thermal spray as a solution. And then they should be included in any kind of specifications if you're making that decision to go towards this as a solution to protect your assets. Because failure to actually understand them and have them addressed in spec will lead to either premature failure and also then obviously consequential damages or to the actual equipment. From the viewpoint of permeability, with IGS, our materials are atomized at a supersonic gas stream, minimizing obviously in-flight oxidation. Our particles are flat because of the alloy modifications that we have done, and are very tightly packed. As I had said, I showed earlier in another slide where did it go? There we go. It again minimizes those potential pathways for permeation if they are not as homogeneous in their development when they're actually being conveyed through the conveyance technology. And so typically, your commercial low velocity thermal sprays can't produce the equivalent particle size and grain structures that HVTS can. So, when you have to keep into consideration, the atomization velocities, your particle size, as well as your particle shapes, to ensure that the cladding that is being applied is going to be the one that's the most impervious to the constituent that is plaguing the asset. Alloy modification, again, I've already mentioned this before, but it's the key thing is that we have to minimize the oxides that are formed through the conveyance of the materials through the conveyance equipment. If we are not controlling them and utilizing unmodified alloys, again, you're going to have the high content of oxides, which leads to permeation into the cladding, as well as there's not a homogeneous development of the actual melted particles if there is no actual modification to the alloy. Residual stresses, that's the big one. All of our alloys, because of the modifications or the additives that we've incorporated into the alloys, we are producing a very low stressed cladding, as applied cladding. There are other solutions out there, such as I had mentioned earlier, HVOF, which is the high velocity oxy fuel. Due to the means of how the particles are melted, you have a very high level of residual stress, which will result in stress cracking in the cladding, and again, creating that pathway for the constituent to attack not only the substrate, but to also greatly affect the effectiveness and the lifespan of the cladding itself. And then commercial wires, such as what's utilized by just TSA or low velocity thermal spray applicators. Again, a lot of micro cracks in the as applied cladding. When you consider residual stresses, the nice thing about having low residual stresses is that the cladding is repairable in that it can be feathered. It can be, if there has been some deterioration of the cladding itself, I'm referring to the HVTS. It can be repaired, giving it a very lengthy lifespan of 10 plus years if before replacement is actually required. Proven performance is the fourth of these 5 key matrix. And we've developed and proven that our HVTS application procedures through a number of very different industry verticals, from the pulp and paper to oil and gas to power generation. And we have a track record that has proven consistently that the HVTS cladding in these systems is very reliable and is really quite dependable. So our performance actually also can be validated through inspections. All of these claddings all can be read through magnetic liftoff. So through inspections and continuous monitoring, we can determine whether or not there's a need for further repairability or refurbishment, as we refer to making repairs to our claddings. And the final one is obviously training and certification. IGS is one of the only applicators that actually train all of their technicians to be certified under an ISO 9001 training and certification system. And IGS stands alone in this proven ability and consistency to produce high quality in situ applications over large areas to a very high level of experience and capability than most other applicators. We utilize this philosophy pretty much right across all industry verticals, not just pulp and paper, but oil and gas, as well as the power generation sector. IGS safety. We believe very heavily in safety. We will bring the same philosophies to all industry verticals. Our safety record is all heavily and documented. It's behavioral-based safety initiatives are always in place. Industrial hygiene monitoring is very important, and it's monitored quarterly. We do a lot of safety investigation techniques should there be near misses, things of this nature. And we also assure that on a minimum, there's at least one on-site safety representative that is exclusively focused on the safe management and risk mitigation during the execution of any project that IGS may be bringing to your particular facility. All of our guys are OSHA 10-hour trained, as well as medical surveillance. And we also have a in-house independent safety department that monitors and continually keeps us on our toes. From the viewpoint of what we would bring into your particular facility, our thermal spray execution capabilities. These numbers are a little bit outdated. They've probably tripled here in the last 5-6 years from the viewpoint of the number of total thermal spray systems, as well as the operational personnel that we have in the field. But the key element here to take note of is that our application systems, with some additional work that we have done in our lab as far as the improvements to the parameters that we utilize within the conveyance systems, is that we can assure you that we can have application rates in the 45 to 50 square foot per shift per conveyance system, so that we can execute the projects within the prescribed critical path that has been designated for this application. So we have tremendous execution capabilities. This final slide is again kind of tying into not only the aspects of how we address safety, but also the overall customer satisfaction, as well as we like to really partner with all of our clients, and we like to share as much information as we possibly can with the client, and get a rating back from the people that we have performed work for, so that we have a great understanding of the safety management of the execution of the project management itself. We're looking for feedback on the ease of doing business with IGS from the viewpoint of professionalism, or the knowledge and expertise of our project managers that we send to site, and just looking for overall grading on your overall experience with IGS once we have completed any specified project for you. And this is just a real brief list of some of the clients that we have executed successfully projects, actually globally, from not only just domestically here in the United States, but also in Canada, as well as a number of operations also in the Japanese and European pulp and paper industries. And that is the presentation. We're open to any questions.
Thank you, Kevin. So everybody's welcome to ask questions in the chat. And I'll monitor the Q&A as well. So we have one question for you. How many projects on average do you carry out, and which countries do you predominantly work in?
Oh, on average, I would say it's a very large number, but if we're talking particularly in the pulp and paper industry sector, or the industry vertical, we're probably annually 30 projects, 30 to 45 projects. And country-wise, obviously Canada, United States. As I was saying earlier on that last slide, we do a lot of the Nippon mills in Japan. We have done some in the European theater as well, for a lot of the larger multi-located paper mills, as well as in the Brazilian and the South American market, Brazil, Colombia. We're also executing projects in those markets as well.
Thank you. And can you elaborate as well? We we see a lot of people replacing their tubes with composite tubes in black liquor recovery boilers, but the
Yes.
intersection between the composite and non-composite still requires protection. Can you speak a little bit more about that?
Yeah, it's been our experience that uh, those facilities that have gone to the upgrade of going to composite, as I said earlier, in the lower combustor of the recoveries, um, we're finding that within a period of time, and that's usually post install of the composite, that they're noticing the migration, if you wish, of that corrosive species up into that composite carbon steel interface, um, which then would require and it's almost an accelerated rate because of the impervious effects, or the not impervious, but the composite works so well in combating against the corrosive elements that they get an accelerated corrosion rate in the first 4 or 5 feet above that composite interface. And it can become very troublesome because if it's not addressed, you will then find yourself having to address the corrosion actually affecting that interface weld, as well as not just the tube, but the actual weld itself between the composite and the carbon tubing. And so we've had a number of mills where we've recommended doing a 4 to 5 foot band above that carbon or above that composite interface to help minimize the effects of that sulfidation corrosion that's evident in that area.
Mm-hmm. And for people who are evaluating their options, maybe they're doing replacement, maybe they're doing welding repairs. If you were to compare it to HVTS commercially, what would you say would be the main benefits, both in terms of outages and total cost of ownership, for these recovery boilers or digesters, etc., or evaporators?
I I think the biggest advantage of considering thermal spray over potential replacement as one is that obviously it's a very time consuming effort to replace panels in recovery boilers. Also very costly. There's also, there has been past issues in past years where supply of the composite tube is very limited and long lead times. And I think that HVTS is a great alternative because of the return on investment from the viewpoint of the less loss of production, because of the rate at which this cladding can be applied. We can do fairly large areas within a recovery boiler in a matter of 5 to 6 days, or as quick as even maybe 2 or 3 days, depending on what kind of critical path window we have and how many pieces of conveyance equipment we would allocate for that type of scope of work. And HVTS is still a great solution for the sulfidation corrosion issues that face these units, in that it's a barrier that has a life expectancy that could exceed 10 to 12 years before having to even consider replacing. So when you look at that from the viewpoint of overall costs in comparison to an upgrade to composite, I think it's a very valid and valuable solution to be considered in comparison to those other means. I mean, weld overlay, again, it's that one's inherited. It's got some very unique issues to it in that, again, it's very time consuming, but you have to address the heat affected zone, what that is actually doing to those tubes and the stresses that it's putting on the tubes, especially when you consider that the average life of, in the United States anyways, the average life of most age rather of most boilers is around 45 years. So it's a very aging fleet. So, I mean, I would not really recommend weld overlay just because of the nature of that heat affected zone and what that could possibly generate as far as future problems moving down the road. Um, Whereas with thermal spray, you don't have any heat affected zones, so it's a great alternative to those types of other solutions.
And this would be specific to recovery boilers. For example, if we're looking at digesters or evaporators, weld overlay would be a viable solution in certain circumstances.
In certain, yes, for digesters in particular, yes, a very viable solution there, because they're not a pressure part. It's not like the boiler where you have to worry about the pressure of the what the operating parameters of the boiler in comparison to digesters are pressurized, but I mean it's you're not having to worry about water leakage, which would be detrimental and obviously very dangerous and deadly in a recovery boiler.
Thank you for delivering the presentation, and thank you everybody for attending. If you have any follow-up questions, I'm just going to put an email in the chat. So it's info@integratedglobal.com. And we use this email for all inbound inquiries that we can then pass on to the right person. Thank you again, Kevin.
Oh, thank you. Thank you, everybody, for joining us.
Go and have a lovely rest of your day. Bye.
Okay, bye-bye.